That was basically the question, right? Where is my... Okay, so for reference, I'm just going to draw the rectangle on the board over here, because that might make things a little easier to keep things straight. All right, so implement a rectangle having corners in the upper right and bottom left, right? Okay, so when you go to implement this thing, you have to decide what fields are you going to use to represent a rectangle, right? And you have actually lots of choices, but the obvious one is to just use x1, y1, x2, y2. Right, so that's the most straightforward way to approach this question if you don't know, if you're uncertain about how to go forward. Right, so int x1, int y1. Right. Okay, so the question says make the fields package private because you need them in question 3. So package private just means no access modifier. Right? So they're not private, they're not public, they're not protected, there's nothing there. So they're package private. Right? There is no package private word, keyword to indicate package private access. Right? There are lots of other ways to do this. You could use one array to hold all of the coordinates. You could use 2 arrays, one to hold the coordinates of one point, the other to hold the coordinates of the second point. You can use lists. Someone used a map, which is really awkward, but you could make it work. Someone tried to use a set, which doesn't make sense because you can't, if you use a set, you can't hold a coordinate 5, 5, for example, because you can't put both 5s into the set. So sets don't make sense. But there's lots of ways to implement this. Next question, provide a constructor that lets you make a rectangle given x1, y1, x2, y2. Right? So what does a constructor look like? It's the same name as the class. Right? What is it? What are the arguments? What are the parameters?
X1 and Y1.
Okay, I'm not, the question is rhetorical. In x2, in y2.
Put a different bracket, put the full bracket.
I'm not putting in round brackets.
Oh, this is the same as me.
All right, so the question also says you have to do some validation, right? So the rectangle can't have a width of 0, right? But x1, y1, x2, y2, they have to be the bottom left and top right, right? So x1 must be less than x2. So if x1 is greater than or equal to x2, similarly, y1 must be less than y2. Okay, so if y1 is greater than or equal to y2, throw some exception. It doesn't matter what kind of exception you throw. I'm just going to write new exception. Right. Why is that complete? Sorry. Throw. Oh, right. New runtime. You can throw illegal argument. It doesn't matter. Just throw some kind of exception. I don't care. Right. Okay, now the rest is simple. It's just this x1 equals x1. Right, this x, this y1, x2, and this. So there's your constructor, right? The next question is, sorry, question? Okay, next question is provide a copy constructor. A copy constructor is still a constructor, so it still looks like public rect, right? What are the arguments? What is the parameter of the constructor? It's another rectangle. So rect, other. Right? What do you do inside the constructor? Well, this x1 becomes other x1, this x2 becomes other x2, and so on and so forth. If you want to, though, you can just write this dot. You can just call the other constructor. You don't have to do it this way, right? So you can just manually set them. Everything would be fine. I'm just doing it this way because it's faster to type. Oh, sorry, I'm being dumb. Other. Right, again, this x1 equals other x1, this x2 equals other x2, and so on and so forth is fine. Next question. Return the area of the triangle. This one is tricky.
Public, you can get area.
Something area.
And
Okay, so the question says return the area of this triangle. So there's no parameters here, right? It wants the area of the rectangle having coordinates this x1, this y1, this x2, this y2, right? Now, when you go to calculate the area, you need the width and height of the rectangle, right? So width. So the width of the rectangle is just x2 minus y2. Sorry, x2 minus x1. The height is just the difference of the y's. Right? The return value is just the width times the height. Okay, so the reason the question marks are in here is because there's a difference happening here with two int values, right? And when you take the difference of two int values, it can overflow. Right? So this question is checking whether or not you recognize that overflow is possible. Right? If overflow is possible, you have to store the result in a bigger or in a wider variable type. So long works here, double or float would be fine. Right? And that means your method must return a long in this case. Okay? But you still have a problem. Right? So when Java sees that, it sees two ints. Right? It sees this x2 is an int. Subtract this x1, that's an int. So Java automatically defaults to int arithmetic, right? Despite the fact that the return type is long. So you have to make sure this gets done in long arithmetic, right? So the easiest way is to cast x2 or put in a long 0 at the front, right? Either way is fine. You can use double too, double's fine. Some students circumvented this problem by using double up here. But then you lost a mark because you're not using integer coordinates. Right. Next question is equals. Equals always looks the same way, right? It's always public Boolean equals big O object. OBJ. Right? So again, equals always looks the same way. So if this equals OBJ, return true. Right? If OBJ is null, return false. Right? The question says a rectangle can be equal to another rectangle, so you have to check if OBJ is a rectangle. Right? So if this get class is not equal to OBJ get class, return false. Right? And then finally the cast, so rect other OBJ. Right? So those, well, the three if statements in the cast, it always happens if you're implementing equals using get class. Right? You don't have to use get class here. You can use instance of, that would be fine. Right? Once you get to this point, you can now just test the if all the coordinates are equal. So return this x1 equals other x1 and, right, this x2 equals other x2 and x2 equals other x2 and this, sorry, this x, other x, this y, and other y2. Okay, now if you used a list or an array, or if you used a list, you have to test if the two lists are equal. So you have to use dot equals. If you used an array, you have to test if the elements in the array are equal. So now you have to either explicitly break out the elements of the array, or you have to use arrays.equals or something like that to test equality. Right? But once you've got that done, so, sorry, after you've implemented equals, you're done question 1. Right? So that's the end of question 1. Any questions on question 1? All right, so next question is some short answer questions. Right? So what is a class invariant, right? A class invariant, something that is true. I guess it should be a condition, but something would be fine. A condition that is always true, that is promised. Right? So that's what a class invariant is, right? It's something that the class promises will always be true. Typically, it involves some condition on the fields of the class, right? So does the rectangle have some invariance? Yes, right? The bottom left-hand corner is always the bottom left-hand corner, right? The upper right-hand corner is always the upper right-hand corner. So this dot x1 is always less than this dot x2. This dot y1 is always less than this dot y2. That's the class invariant.
You mean the width and height?
I do not, well, you could express it as the width and height.
I did that.
Okay, question 3. What is a precondition?
It's also works as well, okay?
It only works if you express the invariance in terms of the fields of your class. So if your class has a field called width and height and they're set correctly, then you could write down the invariant in terms of the width and height.
I can give it some marks here.
Question C. What is a precondition? Right? Precondition is a condition that must be true before calling a method or a constructor. Right? So which constructor has a precondition? Well, the first constructor has a precondition. Sorry, wrong eclipse. Right? That constructor there has a precondition sitting in it. Right? The precondition must be x1 is less than x2, y1 is less than y2. Right? Otherwise, an exception is thrown. Right? So here it's x1 is less than x2, y1 is less than y2. Right? And so the hope here is that you can make the connection between the fact that a constructor has a precondition, right? The precondition is the same as the class invariant, right? If you try to call the constructor and the precondition is false, right? And you go ahead and set the fields without checking them, without testing the input values, then your class invariant becomes incorrect, right? So the preconditions are here in order to support the class invariance, right? Or in order to ensure that the class invariants are true. Final question is the utility class. So save that. So let's make a little utility class. Now remember, in a utility class, everything is static. So this is rect util. Right, so every method that you put into this class is going to be static. Also, in a utility class, you want to prevent the user of the class from making a rect util object. Right, the easiest way to do that is to put in a private constructor that does nothing. You can put in a public constructor that throws an exception or does something. Right? You needed to show some mechanism that stops somebody from making a rect util object. Right? I was very liberal in giving you marks for attempting something like this. Right? So you could have put in a public constructor that did something, and you should have gotten at least 1.5 out of the 2 marks. What's next? There's a method. Oh yeah. So there's a method that takes in. It wants you to write a method that returns a rectangle. But the user makes the rectangle by giving you the upper left and bottom right corner. Right? So you need a method. It's a utility class, everything's static. Right? It returns a rectangle, so it returns rect. Right? It needs a name. You can call it whatever you want. I'm just going to call it make rect. Right? Now here, I'm going to change the name of the variables to indicate that it's the upper right. So x upper right. So x UR. No. This is x upper. Sure, let's do x upper right. Right. Y upper right. Y upper right. Sorry, having a hard time typing. Sorry, what am I doing? Upper left. Right, and you want the bottom right. So X bottom right. Right, so you're going to make a new rectangle. New rect, right? You go back and look at your rectangle constructor. Oh, sorry. You look at your rectangle constructor. It takes in the bottom left and top right, right? So the X coordinate for the bottom left coordinate would be X upper left in this case, right? The Y coordinate of the bottom left corner is going to be Y bottom right. Y bottom right. Right? The X coordinate of the upper right-hand corner is going to be X bottom right. And the Y coordinate of the upper right coordinate is going to be Y upper left. Right? So in other words, you switch the Y's. And that's it. You're done. Make a new rectangle, return the rectangle. Next one. Oh, next method. The method gets a rectangle as one of its arguments. It changes the size of the rectangle. Right? So it changes the size of the rectangle so it doesn't have to return anything. You could put in rect here if you wanted to, but I'm going to leave it as nothing. Right? It takes in a rectangle R. Right? Again, everything's static because it's a utility class. Okay, so it changes the size of R. So it moves the bottom left corner of R up 1 and to the right. It moves the upper right-hand corner 1 down and to the left. Right? Now, this is the reason why you need to make the fields of rectangle you have to make them accessible to this class. Right? So by making them package private, this class is in the same package as the rect, so it can access the fields directly. So now you can write Rx1. So I want to move it to the right, so I just want to add 1 to it. Y1, I want to move it up, so I want to add 1 to it.
Plus 1.
Right. The upper right corner, I want to move it to the...
You can use plus 1 instead.
I can move it to the left. Right. And the upper, I want to move it down by 1. Yes, question?
You can use it by minus 1 and plus 1 instead.
You can write r dot x1 equals r dot x1 minus 1 if you want. But you can't write r dot x1 minus 1. That doesn't change the coordinates. That does not change x1 belonging to r. And the last question, right? Last question? 1, 2, 3. Yes. Is the return true? Check if 2 rectangles overlap. Right? So it's going to be static again. True or false? So it returns Boolean. Give it a name. Overlaps. Makes sense. Takes in 2 rectangles, R1 and R2. Right? The question says, there's a big hint in the question. Right? It says it's much easier to test if 2 rectangles are not overlapping. Right? So R1 does not overlap with R2. Right? If R1 is completely to the left of R2, or if R2 is completely to the right of R2, or if it's completely above R2, or if it's completely below R2. Right? So, how do I test if R1 is completely to the left? Right? Well, its right-hand coordinate, which is x2, right, must be less than the left-hand coordinate of R2, which is x1. Right? So if that's true, right, there's no way that this thing overlaps. Turn false. Right, so this test is, brace, enter. R1 is completely to the left of R2.
And the mean method as well, right?
Okay, so is it completely to the right? So if it's completely to the right, then the left-hand side of R1 must be greater than the left-hand side of R2. Sorry, did I do this right? R2, that's R2. R2, X2. Wait, sorry. Sorry, I'm being dumb. Okay, so right-hand side of R1 is less than the left-hand side of R2. left-hand side of R1 is greater than the right-hand side of R2. Right? Now it's the exact same thing for the y's. Right, so that asks is y2. Sorry, this is y2 is less than, yeah. So this is R1 completely below. Below R2. Right, so that's the top of R1. That's the bottom of R2. Right, so if the top of R1 is below the bottom of R2, they don't overlap. Right, and now is the bottom of R1? Is it greater than the top of R2? Right? If that's the case, then R1 is completely above R2. Right? If all of those are false, or if none of those are true, the rectangles overlap. Right? Now the problem with trying to test for a condition that returns true is that it's extremely difficult or extremely tedious to test if the condition is true. So the problem with testing if two rectangles overlap and you want to test if you want to look for the true condition. Right? So two rectangles overlap if they share at least one point in common. Right? And so the way you can do this is you can test all four corners of that rectangle and test if they're inside that rectangle. Right? Every time you test a corner, you're testing four conditions. Right? Is that between that edge and that edge and that edge and that edge? And you have to do all four. And then you have to do the other way around. You then have to test if any of those four corners are inside the other rectangle. And that ends up being an awful lot of code to write. Right? So it's much easier to test for the negation in this case and then return false. And that's it for the quiz. So the common mistakes, right? So the common mistakes on the quiz are either a failure to test for the precondition or incorrectly testing for the precondition. A lot of students thought that the coordinates have to be non-zero, which doesn't make sense. The rectangle can be anywhere, right? They don't have to have positive coordinates. For the copy constructor, a lot of students made a method. But if you make a method, it's not a constructor. Right? For the area one, obviously it's the overflow issue. Right? Most students figured out that you have to compute the width and height. Right? But I don't know if anybody correctly solved the overflow issue. Equals, the most common problem is some students did test for the overflow or attempted to test for overflow, but they didn't quite get it right. The most common mistake with equals is forgetting that you have to do all of this stuff, right? And putting rectangle in here instead of object, right? Overridden equals always means that, right? And then it always means all of this as well, right? Testing for whether or not the coordinates are equal, most students figured that out. Question 2, it was just a lot of blanks. So people didn't know what an invariant or precondition was. In question 3, that was almost universally missing, although there were students who did put it in. And the most common mistake by far was not putting in static everywhere. Now, I don't think you actually, at most you would have lost half a mark somewhere for not putting in static, and you only lost it once. You didn't lose it 3 times. Right? Shrink was odd. A lot of people passed it in integer for some reason. And then tried to modify the coordinates of this rectangle. But you're not in the rectangle class. You're in a different class. So there is no rectangle, right? You need to pass in a rectangle object here. And then finally, overlaps. Overlaps is, so most students tried to test for do the rectangles overlap? There were a relatively small number of students who actually followed the hint and tested for whether or not they don't overlap. And those are all the comments I have on the quiz. Now, does anybody have any specific questions about the quiz? So at the back, I'm not going to look at your quiz in particular. So at the back? Class average. So it's hard to tell you what the accurate average was because there were a lot of quizzes that were basically blank. So if you factor those in, the average is very low. But if you take those out, the average is probably about a 60. Yeah. With the essentially blank tests in, it's less than 50. Yeah. Yeah. Am I curving the test? I mean, it doesn't make sense to curve the test because someone wrote because there were several students who wrote 28 or above. So I don't know how you curve this test. Yeah, but there were several students who did well. Any other questions? So if you have a question specifically about your quiz.
So this sentence, I have this sentence that's.
Okay, so I will look at this, but this is not the appropriate time to answer this question. Okay, any other questions about, yes?
I can tell only one sentence matches.
Yes, they should. Assignment 4 should be done. Well, it was supposed to be done by last Wednesday. I don't know if they're finished yet. But assignment 4 should be done. The TAs will get assignment 5 to mark this week, and I'm probably going to mark assignment 6. So you get back assignment 6 probably before you get back assignment 5.
Oh, so do you have office hours this week?
Yeah, regular office hours this week and next.
Wednesday?
The regular office hours this week and next.
Not today, right?
Regular office hours this week and next.
Okay.
Any other questions about the quiz? All right, so the exam. The exam is not, so it's not, it doesn't cover everything in the course. It's mostly the object-oriented part of the course. So everything basically from quiz 1 onwards. Right, so you're not going to get asked anything about floating point arithmetic. You won't get asked explicitly about arrays, lists, sets, maps, or strings, right? But to answer a question, you might need to know how to use a string, list, set, or map, right? The lecture slides that are on cue, we didn't get to most of the ones at the end. So this only goes up to lecture 29, I think. Let me just quickly check that. Did we do this? No, we didn't do this. It goes up to lecture 28, up to and including 28. So it doesn't cover the rest of the lecture slides. Right. For sure, you're going to receive a question that involves a data structure of some kind, right? So you're going to be asked a question about a list, a stack, or a queue, right? Implemented in one of the ways that we did it, right? So either using a list, probably not list, using either an array or a linked sequence of nodes. Right? You should expect to see one inheritance question of some kind, right? That inheritance question may or may not involve an interface, right? For sure, you're going to see a question involving composition, right? Or the relationship between classes, right? And almost certainly, you're going to have to implement at least one class that does something, right? Probably involving inheritance and or aggregation or composition. Right? There's already a sample exam on OnQ. I just looked yesterday on Exam Bank. My last 2 exams are on Queen's Exam Bank, if you want to look at those exams. Any questions about the exam? It's a 2-hour exam, so it's roughly twice the length of this thing here, right? If you really understand the material in the course, and if you keep your answers concise, you shouldn't be surprised if you end up finishing a little early, right? It's not meant to be a long exam. Right? It's just testing whether or not you understand,
How much?
if you understand the concepts, the main concepts in the course. Okay, so does anyone have any questions specifically about the exam? All right, so if that's it, are there any questions about the course?
Oh, thank you for keeping me.
Okay, you're welcome. Any other questions about the course? All right, so if there's no questions about the course, we're done for the term. Check your marks on OnQ. They should start rolling in over the next week or so.